This is the Hoover Central Vacuum System. Whether it's for an existing home or a new construction, installing a Hoover system is quite easy. It's an inexpensive procedure that can often be handled as a do-it-yourself project. In new home construction, installation should be scheduled once the house is under roof, but prior to any installation and drywall being installed. The interior stud walls need to be in place. Heating ducts, plumbing, and electrical work should be completed. Before installation can begin, you must first determine the best location for the power unit and determine where the inlets should be placed, and carefully plot the best path of the tubing system to maintain an unobstructed flow from each inlet back to the main unit. For the quietest operation, the power unit should be placed away from the general living area, either in the basement or, as many people prefer, in the garage. With an inlet directly on the canister, a garage installation makes it very convenient to use the car accessory kit. For accessibility, when installing the unit, it should be no less than 12 inches from the ceiling and no less than 12 inches from any sidewall. For ease of removing the dust container, the bottom of the unit should be at least 18 inches above the floor. Your central vacuum unit requires a separate, dedicated 120-volt, 60 Hz, 20-amp, 3-wire grounded power circuit, protected by a 20-amp fuse or circuit breaker with a grounded 20-amp receptacle. The Hoover Central Vacuum Power Unit does not need to be vented outside. However, you should check your local building requirements to determine if venting outside is required. You must first determine the number of inlets necessary for your installation. The average-sized home uses 3 to 4 inlets plus one on the canister. A rule of thumb is to take the total square footage divided by 700 and determine the number of inlets needed. Each inlet covers approximately 700 feet. Inlet valves should be strategically placed for maximum cleaning coverage. Ideally, they should be located in the hallways where there is no furniture to obstruct the hose path when cleaning. For a preliminary layout, begin by working with your blueprints. Check the scale of the drawings. The hose of the central vacuum is 30 feet long. Use a piece of string to represent the 30 feet per scale of the drawing. If the drawings are typically 1/4 inch equals a foot, your string length would be 7.5 inches. Start with the furthest point from the power unit and work backwards, checking to see if the inlet location gives you access to all corners of the area to be covered by that inlet. Keep in mind that the cleaning hose must be able to negotiate around furniture and other obstructions. Repeat the inlet location process by working backward toward the power unit to determine the best locations for all inlet valves. Extreme care should be taken to determine tubing inlet locations to avoid electrical wires, plumbing, heating, and cooling ducts or other obstructions that could create a problem. Once you've determined the location of the inlet valves according to your blueprints, it is advisable to physically walk off the path of the cleaning hose to each inlet, using a flexible 30-foot tape measure or any other measuring device such as a string or lamp cord. Be sure to go to the farthest point to which the central vac hose must reach. Now it's time to lay out your installation kit components. Be sure to unpack and identify the items of the kit before you begin installation. Note the PVC tubing is thin wall, 2 inches outside diameter, schedule 20. Do not substitute. Other PVC tubing may not properly fit the central vac valves. Central vacuum inlet valves should be located at the same height as electrical outlets within 2 feet of the outlet. Once the location of the inlet has been determined, measure for installation of the PVC tubing that will extend from an inlet down through the floor. The tubing should be centered from the floor stud 2.5 inches out from the upright stud. Using a 2.5 inch hole saw or hole cutter, bore through the stud and the subfloor. Sometimes you need to go through the studs. This also applies to going through the top plate. Before cutting holes, be sure to refer to the saw manufacturer's safety directions. To protect the PVC tubing from drywall screws, attach nail guards to both sides of the drilled 2x4 stud. Attach the inlet to the stud. When connecting tubing to the inlet, the shortest 90-degree elbow must be used to fit between a 2x4 wall. If you have to offset your hole location, use a 45-degree elbow to make your connection. Temporary placement of a 90-degree elbow will allow you to get an accurate measurement for cutting the PVC tubing for extending down through the floor. To ensure a proper joint, the coupling needs a minimum of 3/4 inch tubing extending below the surface of the floor. Carefully measure and mark your PVC tubing before cutting. The use of a tube cutter or pipe cutter will help make a clean cut, leaving edges as smooth as possible. A hacksaw can easily be substituted for a tube cutter if one's not available. If using a hacksaw, you need to deburr the rough cut before gluing. When you are certain of the fit, apply solvent to your PVC tubing. For the one-step inlet valve, the electric wire providing power to the nozzle should be run to the nearest electrical outlet box and left for a certified electrician to connect. Always secure the electrical wire to the inlet before proceeding. All wiring installation must conform to the electrical code of the area in which the installation is being done. The one-step connector method has been shown to this point, however the pigtail connector may be your choice. If so, the inlet should be within 7 feet of an electrical outlet. As you continue to install the tubing system, be sure that all fittings are properly oriented so that the airflow is always pointed back toward the power unit to ensure a clog-free system. The tubing and fittings are designed with slip-fit connections, with 3/4 of an inch of pipe projecting into the fitting.